Okay, year 5. Hopefully your book looks something like this, and you can see that I have solved all of the questions that I had on my board. Maybe you went a little bit further, which is great if you did and were able to. Okay, but I stopped at 10 squared minus 9 squared. Okay, and then I started to ask myself some questions. I'm going to look for some patterns, some rules, and I'm even going to talk about maybe adding a little formula into this. So here are the patterns I found. Maybe you found more and you can share those with me in your work. Okay, and I'm just going to put them here so you can see them. Here are the 3 patterns that I saw. I noticed that the answers went up by 2 each time. I noticed that the answers were consecutive odd numbers. It started at 3, went to 5, 7, 9, and so on. And I also spotted that the answer was the sum of the 2 numbers in the question. And what I mean by that, if I just bring my board back in, is, for example, here, 4 squared minus 3 squared, 16 minus 9, equaled 7. And 7 is the sum of 4 and 3. And this seemed to be true of all of my answers here. So, for example, 9 squared minus 8 squared, 81 minus 64 equals 17. Okay. I then looked and took this a little bit further, and this is not an area of maths where I'm an expert, but I kind of wanted to try and make a general rule, a general formula, and here's the one that I came up with. And I'm not saying that this is perfect, but this is the one that I came up with. And perhaps you could test this for me, and I'll show you what I mean. So it looks quite fancy, and I've used the letter N, and N just means number. So I can choose any number and put it in here, and hopefully it will make sense. And my formula is N plus 1 in brackets, and then I square that, minus N squared will equal N plus, and then in brackets I've got N plus 1. Well, I'm going to choose a number. I'm going to choose, for N, I'm going to choose the number 16. Okay, so if I do 16 plus 1 in brackets, that equals 17, and then I'm going to do 17 squared, which I have worked out on a calculator, I'm not going to lie, that's 289, and then I'm going to subtract 16 squared, or N squared, which is, I worked this out on a calculator, 256, and that should equal 16 plus 16 plus 1, which is 17. 16 plus 17, which I think, just doing this in my head, is 33. And I think the difference here, 256 to 280, 50, 60, 70, 80, it is 33, isn't it? It is 33. So my formula may not be perfect, and maybe you can think of a better one, does work. This formula does work. So if you want to, and this is only optional, you could choose a different number, maybe a really high number, maybe in the thousands, maybe in the 10,000s, maybe a million, and put it into this formula and work the formula through, and you should find, you'll probably need to use a calculator, you should find that it works each time, and the formula gives you a general rule for the pattern that we worked out in your book. Okay,